This is mathematics lesson number 2, probability and statistics. The references in our manual, chapter 21, and in the NCEES handbook, it will be pages 7 to 10. If you look at the very first page of chapter 21, you'll see a summary of the 7 subjects that we will be covering. The first subject is combination permutation. After that, we'll do the laws of probability, followed by numerical events, measures of central tendency, measures of dispersion, probability density functions, and probability distribution functions. We'll be spending the next 90 minutes covering these subjects, and then we'll be going on to 90 minutes of problem solving. Okay, let's start off now talking about combinations and permutations. Suppose there were n objects and we wanted to group them in such a fashion that we would have groups of r, taken r at a time. So we're dealing with n objects, r at a time. Then the number of combinations we can form, written in this fashion, n, r, with a couple of brackets, sometimes written as a big C with an n up above and r down below, or sometimes it's simply written as C parenthesis n comma r. They all mean the same thing. But that's equal to n factorial divided by r factorial times n minus r factorial. And of course r must be smaller than n, at least less than or equal to n. Now let's take an example. Suppose I had 3 objects and I want to take them 2 at a time. Then the number of combinations I would have would be 3 factorial divided by 2 factorial times 1 factorial. The 1, of course, is n minus r, and that's equal to 3. So there are 3 combinations I could form. Well, let's say the 3 objects were the 3 letters A, B, and C. Well, I can pair them as A and B, A and C, or B and C. So there are the 3 combinations I'm looking for. Now notice that I'm not concerned about the order. I am not distinguishing between AB and BA, or AC and CA, or BC and CB. That's going to show up later when we talk about permutations. So a number of combinations would be easily to calculate based upon this formula, which we'll be using time and time again. It will show up again when we start talking about the binomial distribution, which is a very important distribution we need to be studying. So remember this formula, n factorial over r factorial times n minus r factorial, and you can find this on page 7 of the NCEES handbook. And become familiar with that page and the pages between 7 and 10, because we're going to find some other formulas there. Now, if we're dealing with permutations instead, P's number of permutations, we would have to use a different formula. In the case of permutations, we write this as P n comma r, and this would be the number of ways I could permute the objects that I'm working with. So this would be equal to n factorial divided by n minus r factorial. Now let's take an example. If n is 3 and r is equal to 2 as we had before, then we will have three objects, A, B, and C. We can take two at a time. This becomes 3 factorial over 1 factorial, which is equal to 6. So I have AB, BA is different, AC, CA, BC, and CB. I now have 6 different permutations of 3 objects taken 2 at a time. So you can see we have more permutations than we have combinations.